Hello, grade 5 teachers. Let's have a look at some ways that we can connect computer sciences into your Earth Systems unit. Your computer sciences curriculum in grade 5 has students looking closely at design thinking as well as designing computational artifacts and designing artifacts. Students are being asked for the first time to relate a block of code to an outcome or behavior, or to explain what several blocks of codes will do when executed together. So this is the first time students are actually asked to do some block-based programming. You should have some opportunities to have students create projects in something like Scratch that shows knowledge from some of their other subject areas or curriculum areas, and you can meet these computer science skills and procedures while you're meeting those other topics. We know that the computer science curriculum, all the way from kindergarten through grade 6, covers 3 overarching ideas. It talks about students understanding computational thinking, the design thinking process, and also creativity. In grade 5, the design thinking process comes into play explicitly in some of your outcomes, where students are really being asked to understand design thinking and to apply the design thinking process to things that they're doing as well. In grade 4, students are asked to create an artifact, and in the knowledge area, it tells us that artifacts are everything from algorithms to prototypes to models or experiments. So pretty much anything that you have students building or creating can be considered an artifact and is therefore has them working on this computer science outcome. We see the outcome or that skill and procedure come up also in grade 5, along with the skill of engaging in the design process to create computational artifacts specifically. Now, a computational artifact doesn't mean a computer program only. It can also mean an audio video presentation, a slideshow presentation, or a web page. So asking students to create something on a computer is a computational artifact and is meeting this computer science skill, or I should say both of these computer science skills, while also meeting other outcomes. In addition to designing the artifacts, we see some skills around proposing enhancements and developing multiple iterations of an artifact. This is directly connected into the design process, where we would have students, create and test and then go back and refine and test and refine and test and refine until the end goal was met properly. Having students do reiteration, it's hard for them. They do not like to be told to redo something or that something could be better. So spending specific time working through having students develop those multiple iterations is going to give them good critical thinking skills and problem solving skills, and also help them work on perseverance, which is really needed to be an effective designer. So jumping into the specific skills and procedures that are in Earth Systems and looking at some ways to connect some of that computer science content into there is a number of skills and procedures here in this slide where we're really learning about climate and weather and distinguishing them from each other and determining what the characteristics of each is, talking specifically about climate here in Alberta, comparing our climate to other climates. So these are all a very specific content, specific skills and procedures, but we have opportunities when we're teaching these to students and working through them to also bring in computational thinking, like is here on this slide. So this is just some examples of how we could be working through computational thinking when we're doing these other things. We're doing decomposition when we're breaking climate and weather down into their different parts. If we're breaking the different climate zones down into their different attributes, we're working through decomposition. We can look for patterns and connections between climate and weather, which is over here in the skills and procedures for this Earth Systems topic. We can also falls into the pattern recognition piece of computational thinking, abstracting, determining which of those key weather characteristics are the ones that do in fact determine climate. We can also make a connection to how weather systems themselves are abstractions. So meteorologists, scientists collect a lot of data that we wouldn't understand, but then our weathermen that we see on TV or hear on the radio or who post on the web for us break it down into something that's very simple for us to understand, even including just simple pictures. So that's a really good example of abstraction that you could make a connection to for your students as well. And grade fives don't need to know what abstraction is specifically, but grade sixes do. So introducing it in grade five is going to help them understand that concept better when they get to grade six as well. And then we can always go that extra level into the algorithm design, which is maybe more traditionally connected to what computer coding is, but writing a set of instructions for anything is algorithm design. So asking students to write a set of instructions for how to use weather to determine climate. So we've learned all this. You now know how to determine climate based on, weather conditions. Write a set of instructions that a machine or another person could follow. And we're going to be really getting deep into the skills and procedures here from Earth Systems because we're asking students to essentially instruct, and we're also transferring in those computer science skills. Again, so lots of skills and procedures in Earth Systems for you grade fives. It would have taken many hours for me to create a presentation that covered each skill and a way to connect in computer science. So I'm going to try to just generalize a little bit more and show you ways that you can make those connections no matter which of these skills specifically that you're looking at. I have dropped our empathize guide down next to the First Nations, Métis, and Inuit skill. You will see, if you see these connections videos for your other science topics, you're going to see that empathy pops up for me every time that we're talking about those perspectives. We're looking at someone else's perspective. We're asking students to put themselves in their shoes or to understand their views on something, which means we're definitely asking students to do empathy. That first piece of design thinking. Design thinking is a key piece of your CS curriculum. So anytime we can be doing those skills, we definitely want to be doing that. So again, now as students they're examining tools and they're tracking weather and they might be building some simple tools, there's that design thinking. We could have a whole activity on building some type of tool to measure weather. We're going to be doing design thinking while we're doing that. We're going to be hitting these computer science skills because students are going to be designing an artifact. If we ask them to do it on the computer, then they're designing that computational artifact. We can ask students to discuss examples of design. So say we're looking at weather tracking systems and how they've changed over the years. And, what do you think it was like to only be able to determine what the weather would be based on, standing outside and looking at what was happening, to where, now we evolved to, being able to measure the temperature and test some atmospheric conditions. And now with technology and the complicated computer systems and the satellites and everything that they have, how we are able to get information about weather, far out in advance, and they're able to warn us about weather events that are coming. So we can be talking about weather tracking and the advances in the history, and we're covering these computer science skill while we're also doing that. I'm going to see here, ask students to construct a sample weather map. That might be something that they could do digitally on a Chromebook. Maybe it's on a slides presentation and we're just making a map. Okay, extend it, ask them to do that and make it interactive in a program like Scratch. And we can, check off all of those computer science skills at the same time. Students are going to get into that block-based coding if we're asking them to use a block-based coding program. Anytime we can connect that into something else, we're definitely going to see the learning elevated. They're going to get to that deep level of understanding because then they're transferring it into other areas as well. So, if we're having conversations about climate and the plants and animals, for example, we would start by talking about, well, what kinds of animals live in Alberta, and what kinds of animals do not live in Alberta. And now let's talk about, well, what do you think is it about these animals? Why don't we have lions in Alberta? Why don't elephants live here? Well, because it's too cold. Oh, so our climate determines, what can live here. And we're making these connections. We have those computational thinking conversations. And then if we were to ask students to maybe represent this in some way, we could then draw in computer science. We could ask them to create a computational artifact. Again, if we really want to go deep into computer sciences, we could ask them to create something in a program like Scratch and use that block-based programming to show us how climate affects what lives. So maybe we're going to represent a particular climate zone and show the plants and animals that live there. And we can do that through a program like Scratch. So we're going to be covering all of these things and showing what we know about Earth systems and also showing what we know about computer sciences. Again, opportunity to create those artifacts. It could just be an artifact, as we saw way above in this slides presentation. As soon as we hit, again, it being a slides presentation, maybe they're making a video, they could even be recording a song. Any of those things qualify as a computational artifact. I'm meeting my computer science curriculum along with these Earth systems. Ask students to create some type of a presentation for the class. You're going to check these off, looking at these things specifically, breaking down harvesting practices and comparing off with climate. We're going to be working in that computational thinking as well, looking at different types of conservation practices. We might look for patterns. What is the same between these types of practices? Do they do things differently in a different part of the world? Do all people practice these conservation practices? These conversations are all going to be valuable, and also touching into that computational thinking, asking students to create some type of product or artifact. You're also going to be connecting in that design thinking that they're asked to do in grade 5. Examine how weather conditions and animal behavior can be used to recognize weather patterns. Here's an opportunity to do some simple algorithm design while we're also learning about migration and weather patterns and animal cycles. And so asking students just to come up again with some simple sets of instruction. Can you tell the bear what to do when winter comes? What instructions would you give a bear that doesn't know how to hibernate? Or what instructions would you give the geese? They don't know what to do. And so we're learning about those animal behaviors, but we're also diving into our computer sciences. So we have in the Earth systems, we have these skills and procedures that are also in energy. So we will look at these in Earth systems and then also again in energy. If you've already watched the energy video, you can probably just stop now because you're going to find it's exactly the same as what you're about to experience. Otherwise, let's talk about this other part. So this is the part 2 of Earth systems, which is also part 2 of energy. And for grade 5, we're talking about, renewable and non-renewable resources and sort of the advantages and disadvantages of using them and comparing how different provinces use their natural resources. So there's lots of opportunity for conversations here. We can definitely be doing some empathizing and having some deep critical thinking conversations and being creative thinkers about how to solve some of our resource issues and all of those things. starting really basic, a sort. Anytime we're looking at attributes specifically to group something up, we're doing decomposition and some computational thinking. Just having students analyze and think critically about all of the different parts of any type of concept that we're covering is going to bring that computational thinking in. Asking students to now, again, if we ask them to convey what they know about renewable and non-renewable energy through some type of artifact, it could be a slideshow presentation, ask them to do a scratch project, and we have these opportunities to also check off some of those computer science skills and procedures while we're doing these energy and earth systems topics as well. So those are some ways that you can connect computer sciences into your earth systems unit. I hope you enjoyed.